Hello, welcome to Soft Data Analytics and Consultancy. I'm Isaac Ajao. I want to demonstrate to us how to detect multicollinearity in data using STATA. First of all, I want to talk about multicollinearity. Multicollinearity occurs when two or more predictor variables in a multiple regression model are highly correlated, meaning that one can be linearly predicted from the others with a substantial degree of accuracy. And this, of course, will lead to issues. Issues range from unstable coefficient estimate, inflated standard error, reduced predictive power. And that's why we have to get rid of it. How do we detect this strong relationship among our predictors? Now, to detect this using STATA, we have four methods. We have correlation matrix, when we check the correlation matrix and we detect high correlation coefficients, typically above 0.7 or below minus 0.7. This indicates multicollinearity, and this is the code. Just type correlate or just see, or I will demonstrate it for us. So these are the independent variables. We will not include the response variable, which is dependent. Another method is VIF, that's variation inflation factor. So once the VIF is greater than 10, this indicates serious multicollinearity. So the first thing I'm going to do here is to run. You cannot detect, you can't use VIF before we run the regression. So we need to run the regression analysis, which is then we now type on the command prompt VIF, and we generate the value for us. So it will only show us the VIF value for the independent variables. Then the next one is that of tolerance. Tolerance is just the reciprocal of VIF, that's 1 over VIF. So low tolerance, like less than 0.5, is when we have high multicollinearity. Of course, you should know when we have a value in VIF and we are taking the reciprocal, you should know that the lower will mean what the higher mean. So the condition index is the last method. That's the fourth method of detecting multicollinearity using STATA. This method involves decomposing the matrix predictors into its eigenvalues. So condition index above 30 suggests multicollinearity. But before we can do that, we need to install this. It's a package we need to install on STATA before we can make use of this. So once this is above 30, that is a detection of multicollinearity. So let me go to STATA. Now, I want to make use of the popular auto data. Now, I want to make use of price as my response variable. Price as my response variable. The other ones as my factor or the independent variable. Okay. Copy page. Should be able to copy all of them. So I want to regress. Can write, just type regress or reg. So you can see the R square is 0.598. The adjusted is this, but generally it's significant. But when you look at this here, there's only one or two that are significant, and that is what we are looking for here. See, we can't really say this is we can't really say there's multicollinearity currently say the predictors are collinear unless you carry out the necessary test. So we can correlate all of them. Let me bring this and put correlate there. Correlate. You don't need to put price there. So you can see anyone above 0.7 is not okay. You don't expect the correlation among a predictor to be so strong. So anything above 0.7 here is bad. It's not okay. That's a sign of collinearity. All of this weight, you can see where we have 0.86, these are greater than. Then anything less than 0.7 also negative side. So this is it. So we can check from this place. So we can fish them out. Now another method is the one that will give us straight answer. When we carry out the regression analysis, we have done it. So we can just type VIF now. That's the variance inflation factor. Just type VIF. VIF give us this. You can see now. One thing with VIF is that we just go straight to the predictors, the independent variable. So the VIF for this, for weight, you can see is 21.36, which is above 10. Once it's above 10, don't forget showing it to us the right time. The condition. Once the VIF is greater than 10, it means there's a serious multicollinearity. So you can see weight is greater than 10. It has collinearity with the remaining values, independent variable. Same thing with this. All these three can be dealt with. Now, once the tolerance also, which is 1 over VIF, is less than 0.1, there is serious multicollinearity. This is less than 0.1, less than 0.1, you can see. All this one here. Okay, so we can pick any of these, either VIF. What is important is interpretation. Though generally the VIF, the mean of the VIF is 6.9. Some people leverage on this. They say once the mean is this, so we can. But if we really want to do the right thing, these three has to be solved. So that we remove them, or we carry out another test to adjust those values. Then the last method is that of condition index. Condition index, say we need to install it. To install it is this SSC install code diag, and then I can just type it or copy it. Yes. Then can bring all of this again. Just the predictors, copy. That is it. You can see the condition number is 97.18. This is bad. This is not okay. This is serious multicollinearity. In econometrics generally, a lot of people believe we can only reduce multicollinearity, we cannot remove it. But in this case, this is too much, because this is greater than 30. Any condition, any data that has condition number of greater than 30, that is sign of serious multicollinearity. This is 97.18. So, in summary, these are the 4 methods we use in STATA to detect multicollinearity. Next video, we talk about how do we handle multicollinearity when it happens in econometrics analysis. Thank you.